Section 10.5, abuses of statistics. We're going to talk about ways you can but shouldn't abuse statistics and things that you should be aware of when people present you with statistics to say, I don't know if that sounds quite right. Because that's really, as a consumer, what you should be doing when somebody gives you some information and say, does that make sense to me? Are they really presenting that in the way that is what they're saying? You know what I mean? Does the statistics really support that? All right, so sampling process. Sampling process means how the data was collected. So the data can be collected in appropriate ways, and it can be collected in ways that are not appropriate. So some of the kinds of questions to ask are, who was asked? So let's just fill all these in, and then we'll talk about them a little bit. How many people were asked? How many people responded? Was the sample random? And how was the question worded? Who was asked? So if you ask, who are you voting for president for, and you ask only people on OBU campus, is that going to be reflective of the entire state of Oklahoma? Probably not, right? Who was asked? If you ask only women a question as opposed to women and men, is it going to reflect everyone's opinion? Probably not. Okay, so the who was asked question. If you asked only people who are in their 20s, is that going to reflect everybody's opinion? Probably not. So the who was asked matters. How many were asked? If you ask 10 people, is that going to be a good reflection? Probably not. So it takes a lot of people before it actually even makes sense to report it, right? Hundreds, thousands potentially, depending on what you're looking at. How many responded? So I could send out a survey to everybody on OBU campus asking them questions about how they feel about the GC's food. Seems like a reasonable thing to do, right? But if only 100 people respond, that might not make a very good, statistic, right? 100 people respond, but I asked 3,000 people, 2,000 people, something like that. How many people responded out of how many were asked? Not only how many responded, but why? Did only the people who hate it respond? Did only the people who love it respond? You know what I'm saying? Or did only the people who absolutely hate it or absolutely love it respond? That is, the people who were sort of in the middle are just like, I don't really have an opinion, so they didn't respond. That's where I usually fall when I get surveys. I don't respond a lot of times because I don't really have a strong opinion one way or another. So I don't really care about the responding part, okay? Was the sample random, right? Or did you somehow hand select, either intentionally or unintentionally, the people who were chosen? Right, so like if I sit outside of Wood Science Center asking questions of people that come out the door, is that going to be random? Well, not really, because only the people who have classes in Wood Science Center, hence people who are taking science classes, which probably means a lot of science majors, not everybody, but a lot, are the only people being asked. So that's somehow going to be slighted, right? It's not going to be representative of the entire campus as a whole. How is the question worded? This is actually a really good question. Did we word it in such a way that people understood what they were answering? So sometimes questions are just worded badly, and you can't even figure out if you answer yes or no if what you said meant what you thought you meant. So if somebody says something like, are you in support of not having a casino? Okay, well, I am in support of a negation of something. That's awkward wording, right? So wording for things matters. The other thing that matters is it matters how you're asking and who it's asking. For instance, if you're asking OBU students, do you drink? Are they going to answer honestly? Maybe not, right? Because they might actually feel like the right answer is this. This is like when you ask the questions in church, the answer is always Jesus, right? The answer is always Jesus, the answer is always Jesus. Well, the right answer is this. It may not be the answer that's actually truthful, so you have to be really careful about how something's worded, especially if it's about a morality issue, right? If something is feeling like, I should answer it this way, but this is how this is really reflective in my life, I might not actually answer in a truthful way. Okay, so these are different ways that can cause error in the way that something's reported because of sampling issues, how people are asked. There's also representative issues, how data is represented, or graphical representation. So if a title is left off, It might be that the information was left off on purpose so that you don't really know what the title was supposed to be. Labels on the axes. Maybe the label was supposed to be months and you're assuming the label meant years. That would be a different representation, right? Source of the data is included. So if this is real statistical information, they need to tell you, they need to cite where the information came from. You know, it came from a study that was done at Harvard University in 2014 among, graduate students. There's detailed information about where the information came from if it's really truthful information. A key to a pictograph or stem or leaf plot. We've talked at length about having all the details on our graphs. Details left off are sometimes left off to make the viewer or the reader think something that's not true. Right? All that information's on there. A few other things. Uniform size on symbols. We've talked about that. You do a pictograph and the pictograph has hearts everywhere. Every heart should be about the same size, right? You make some hearts big, some hearts little, and it skews the information. Scale. Does it start with 0? If it doesn't, you need a break in the graph. We drew one of those the other day. I think it was, what was it? Was it jumping heights? Was that the one I did? Something I did where I broke the graph apart at the very beginning because the heights actually didn't start at 0. I think that's what it was, and the years didn't start at 0. Scale, are the numbers evenly spaced? So from the year 1999 to the year 2000 to the year 2001, is there an equal amount of spacing? And I'm not asking for you to be super duper extra specific even when you draw it on your own, but it should be a reasonable attempt. All right, you should make a reasonable attempt to make your graph look like that the scaling is equally spaced. So if a graph is drawn in such a way that the scaling is not equally spaced, it's usually meant to make it look like something that wasn't meant to be really reported. The last one, 2D and 3D misleading effects. I'd like for you to grab your book out, and I'm going to tell you which page to look at.
I know.
606. Taylor just had it marked in her book exactly like I want it. 606. Take a look at page 606. 606 is a fantastic representation of how you can use 3D graphs and 2D graphs to mislead the viewer. We're going to start at the very top of that page. Do you see the very top of the page where it's got a big old giant cube and a little tiny cube? Both the 2D effect and the 3D effect make this misleading. If you look at the information, they actually talk about 20 millions of boxes, the number of millions of boxes. The little blue box is 2 million boxes sold, and the big box is 8 million boxes sold. But if you look at that graph, it doesn't look like it's 1/4, does it? Both the area and the volume make it look like there's this huge difference in the value of the data being reported. Here, look at your pie chart at the bottom. The pie chart's a fantastic pie chart. The percentages are on there, but if you look at that percentage of recreation at the bottom, it says 27%. I mean, 27% is almost the same as 23%, and the 23% is in the top corner in blue. Does that blue sector look like it's about the same size as the green one at the bottom? Not at all. It looks way smaller, that top blue one, right? And it's because they've turned this graph that should be two-dimensional, pie chart, into a three-dimensional viewing of it, which makes it look like something that really is not represented there. Okay, is everybody with me on that? These are different misleading effects. So as you're taking a look at the homework in this section, there's no group work listed because it really is something that I would encourage you to find a partner and actually talk through some of these with them outside of class. Because whatever you see as a misrepresentation might not be what somebody else sees. It's you get better at noticing the misrepresentations the longer and the more you do these problems. Okay? Everybody good? All right.